Dr. Wuebbles is a Harry E. Preble Professor of Atmospheric Science at the University of Illinois. Also, though, he is a professor in the Department of Atmospheric Sciences, as well as an affiliate professor in the Departments of Civil and Environmental Engineering and in Electrical and Computer Engineering at the University of Illinois. He has authored over 400 articles relating to atmospheric chemistry and climate issues. He has been the lead author on a number of national and international assessments related to climate change. He shares the 2007 Nobel Peace Prize for his work with the International Intergovernmental Panel on Climate Change. He has been a member of a federal advisory committee that assessed and in 2009 published a report on the potential impacts of climate change on the U.S., and he is the coordinating lead author for the major international IPCC assessment of climate change that was published in late 2013, and then was a leader in the U.S. National Climate Assessment that was published in May of 2014. And he's one of only 6 scientists selected by the U.S. Academy of Sciences to work with counterparts in the United Kingdom Royal Society on a special report on climate change that was published in February 2014. So I'm now honored to introduce to you Dr. Don Wuebbles with his program, Our Changing Climate, the 2014 U.S. National Climate Assessment. Thank you so much for being here.
Thank you all. I'm also a farm boy from Southern Illinois, Carlisle, Illinois. So we're going to take a little bit of a look tonight at climate and how it's impacting us and what it means for our future. I'm going to largely give you information that comes out of 2 major scientific assessments. One is the IPCC assessment that Nancy mentioned that had 259 authors, very extensively reviewed by thousands of people around the world, and this is just one of 3 working groups. This is the science, the physical science. There's a working group on the impacts on the world that has an equally 1,000-page report, just like ours, and then another one that looks at policy options, and that one just recently came out. Then I'm going to talk, in addition, about the 3rd National Climate Assessment, and I've been coordinating one of the leaders actually in the last 2, and I was involved in the first one but wasn't a leader. These are based on a requirement that Congress made through the 1990 Global Change Research Act, such that there be an analysis every 4 years of what is the state of the Earth, of the climate, and how it's affecting the United States and what it means to the people of the United States. And so we'll take a little bit of a look at that. I do urge you to go to the website, because then you can see the entire assessment, the full 880 pages of it if you want to, but you can also focus in on what you might be most interested in. For many people in Illinois, it's the Midwest and what it means to us, or maybe you have coastal property in Florida, not so advised these days, but we'll talk about that later. If you're planning on keeping it for a long time period. I'm kidding around. But you can find a number of things that you might be interested in, or maybe you're interested in agriculture, or interested in water resources or other issues, and you can find details about that. This latest assessment was the most comprehensive of the 3 that has looked at how climate change is affecting our nation now and how it could affect it in the future. Just like the international assessment, it had about 300 authors from all areas, by the way. There's some people from government, some from academia, some from business, essentially all walks of life. A lot of really bright people. And on top of that, there was a 60-member federal advisory committee that were leaders across a number of different sectors across the country. We went through a very extensive review process, twice by the National Academy of Sciences, as well as a major public review of the assessment before it was published. The idea was, let's make this as clear as we can to the public. We had professional writers working with us to make it, take out all the jargon, all the scientific jargon, and try to make it very clear to the people why what is going on with the climate, both here and around the world, but also what does this mean to us? Why is this important? And so I do urge you to go to that website. Well, probably the most important conclusion from that assessment, and there's a number of them, and I'll go through them as we go through the talk, is that human-induced climate change. Climate change is occurring, and it's human-induced. And we'll talk about why that's the case, has moved firmly into the present. This isn't something, this is going to happen decades from now, just decades from now. It's happening now. And it's affecting people in the US, and it's affecting people throughout the world. And I'm going to go through a little bit of that evidence. I can only do so much in an hour. First of all, if we look at the temperature record, there's many, many thousands of observations taken around the world of temperature every day. Different organizations around the world, and here's three of 5 different organizations that look at all these different measurements and try to analyze their best analysis of which measurements are good. Is some measurement taken too close to a air conditioner or something, and so it gets distorted. They try to throw out things and try to get the best analysis we can of temperature across the planet. And what we found is that the temperature overall has increased about 0.85 degrees centigrade, about 1.5 degrees, a little over 1.5 degrees Fahrenheit worldwide. And a little bit of fits and starts to that, and I'll get to that a little bit later. Then if you look at proxies to temperature, because we only have data going back about 150 years, and best data since about 1900, so a little over a century. You have to use proxies for temperature. So you can use boreholes in soil, you can use tree rings. Everybody's probably heard of tree rings and how you can gather temperature information from that. Many, many other sources. You can look throughout the world, and people do this. But best analysis are for the Northern Hemisphere. That's where we have the most data. And so if you take that temperature record from the left, going back to 1900 and before, Heather Center in the UK is shown there, plus two US analyses, one from NASA and the other from NOAA, National Oceanic Atmospheric Administration. And you take those analyses, and you see they give almost exactly the same results. And you see year-to-year fluctuations, that's expected. Climate is the long-term changes in weather. It's not, so we're not interested in what's happening in a single year. We're interested in the long-term changes. But if you take that temperature record and you try to go back in time and look at the upper right, you see that this most recent decade is actually the warmest decade in at least 1,400 years based on analyses of these proxies, but perhaps going back 2,000 years, which is about as far back as that data, as a clear Northern Hemisphere analysis can go back right at the moment. So this is a very unusual time we're in. So recent decades are much, much warmer than the past. Well, temperatures, you'll hear this stuff, global warming. Scientists have always called it climate change, by the way. The media started calling it global warming about 20 years ago, and it really stuck. And so sometimes you'll hear us say global warming, but that's because public expect us to say global warming, because that's what the media has said for so long. But we usually don't talk about that because it isn't the temperature that's the most important change. It's really the change in severe weather and other concerns, and I'll talk about some of those as we go through. Well, it isn't just temperature that's changing. We're seeing the sea levels rise. We're seeing more water vapor in the atmosphere, which is a good indicator that the atmosphere is indeed warming, because basic physics tells us that a warmer atmosphere holds more water vapor, and you get more evaporation. And glaciers are decreasing. Over 90% of the glaciers in the world are decreasing, on and on and on. Sea ice is decreasing, land ice is decreasing, on and on. So there's many, many indicators, and these are just a few of them, that our climate is changing. Just an example, a couple years ago, my wife wanted me to take her to Alaska. Barbara asked when we were very young, we started going together, there were certain things she wanted to do. Well, now that we've been married almost 45 years, I'm finally getting around to doing some of them. And because I'm a scientist at work. So I actually got her I got to go to Glacier National Park while there were still glaciers there. There are not many, but they're rapidly disappearing. But we did go to Glacier National Park, and we went to Alaska. And I was really struck by, in the 1940s, there's this huge inlet if you take a cruise into Alaska, in Glacier Bay National Park, that was totally covered by ice, which you can see on the left. Now you go for long distance by ship to get to the very end of that, right up next to the rocks, where you can see the remnants of the glaciers. Huge decrease. Over 90% of the glaciers in the world have decreased like this. Not every glacier, nor do we expect every glacier to, because some are affected by some local weather that is driving a microclimate. But we do see a huge decrease in glaciers. We also see a huge decrease overall in land ice in Greenland and Antarctica. That in the future is going to be really important to looking further at sea level rise. At this point, sea level rise is primarily due to the oceans expanding, to the fact that they're warming. It's not just the atmosphere that's warming, it's also the oceans. We did an analysis recently in my group. This was done by one of my graduate students. It's kind of a prelude to a more major study. This just looks at that same temperature record, going back over the last 150 years using the UK measurements, where you didn't see much going on to about 1900. And after 1900 to about 1940, there was a significant increase. And then from 1940 to about 1965 or so, maybe even a slight decrease, if not, certainly not an increase. Then we had a very significant increase in temperature from about 1965 or so till around 2000. And in the last 15 years, it's been kind of quiet. 2014 was still the warmest year on record, followed by 2010 and 2005. But nonetheless, we haven't seen the huge changes like we had. Well, we broke this down, and we did 10-year running averages, 30-year running averages, and then 60-year running averages. Well, 60-year running averages, you can see the long-term change. Start talking about climate. We're seeing this very significant increase going on. But if you look at the 30-year running mean, which is the second one from the bottom, you actually see a cyclic behavior in it. And we think that that's likely associated with the 60-year cycle in the oceans, which often gets called the AMO, the Atlantic multi-decadal oscillation, but in fact is seen in most of the oceans. And recent analysis of this recent slowdown in temperature appear to be associated with the oceans and may be associated with this long-term cycle, which this tends to suggest. Well, as we go back into the other phase of the cycle in the next few years, that means we're likely to see another huge increase in temperature for decades to come. That's my real worry. If we break down the temperature record I just showed you by decade, you can see that over the last 4 or 5 decades, there's been a significant increase worldwide, and that's, as I mentioned earlier, this last decade was the warmest by far. Now, looking at temperatures around the world, this is looking at 1901 to 2012. Some areas we don't have good enough measurements. Those are white areas here, because these are land-based measurements, or land and ocean, so it doesn't fully account for the satellite data, which can go further in latitude. And also it's trying to go a period well before we had satellites. But you can see almost all of the areas of the world have seen this very significant change in temperature, including the oceans and the atmosphere. And this is the air above the oceans, not the oceans themselves. And the oceans themselves also have seen an increase. There's 2 exceptions here. One is the area off of Greenland, where we're getting a large amount of melting, both from sea ice in the Arctic and also from land ice from Greenland, that have resulted in a lot more fresh water in that region, which has changed the circulation patterns a little bit for the ocean circulation, and result in a little slight cooling in that area, fully expected. And the other one is actually the southeast U.S. which is not as quite as well understood. We can go into that further if you want to later, but it's kind of interesting. This looks at the U.S. in more detail. This is from the National Climate Assessment. And then just like we saw worldwide, the temperature in the U.S. has likewise by decades seen this overall significant increase. And most of the area of the U.S. has seen a very significant increase in temperature, which is these red areas. But there's also this white, light blue area that indicates a slight cooling. But it's a very small area relative to the overall U.S., but it still exists. Overall, we've also seen an increase, not just in temperature, but the frost-free season has increased, which we correspond to what's called the growing season. In the Midwest, we broke, in the National Climate Assessment, we broke in the U.S. into various regions so we could try to do better analysis on a regional scale. In the Midwest, we've seen an increase a little over a week overall, but out west, it's gotten much, much longer, by almost 3 weeks in much of the West. Precipitation, overall, precipitation has not changed all that much in the U.S. Some areas have seen an increase, particularly in the Midwest and the Northeast, and parts of the northern part of the Great Plains. But some areas have also seen a decrease, particularly in parts of the Southwest and the Southeast. And those areas have had more droughts as a result. And the areas with the biggest increases have had more floods. Talk more about that later. Along that lines, Americans are already feeling the effects of the increases in temperature in some types of extreme weather, but also in sea level. And those are the things that are really affecting us, extreme weather and sea level rise. Not so much sea level rise too much yet, but that will be coming. We're seeing important trends in heat waves. They're generally increasing throughout the world, likely to become longer and more severe. Cold waves generally are decreasing. Doesn't mean we can't have a cold wave like we're having this time period right now because of the stationary highs up in the Arctic, sending cold air down our way. There's been some argument, is that related to climate change? And we're still trying to understand, in fact, whether there might be a relationship. There's several hypotheses out there. More precipitation is coming as larger events. That's very, very clear. We're seeing very significant increases, decade by decade, in the amount of precipitation throughout most of the country coming as larger events. Farmers here in the Midwest certainly see this in the springtime for sure, when it's getting harder and harder at times to get out in the fields and get planting done. We're seeing increasing risk of floods in some regions, particularly the Northeast and the Midwest, and droughts increasing in other regions, particularly the Southwest and Southeast. There's been an increasing intensity of Atlantic hurricanes over the last few decades, and that tendency is likely to continue. All of these tendencies are likely to continue. In Illinois, we've seen several cases of extreme flooding, but we've also seen the drought of 2012 that have a very significant impact on agriculture. Across the nation, NOAA, the National Oceanic Atmospheric Administration, for the last 35 years, since 1980, have been tracking what are called billion-dollar weather events. And this is just up to 2013, so I don't have last year's in it. Overall, they've seen an increase in the number of such events in recent years, and also in terms of the dollar amounts. Recent years have been averaging $80 to $100 billion a year, just counting those that are above $1 billion events. So, if it's less than that, they're not counted in this analysis. And that includes things like droughts in some regions, particularly major effects have been in Texas, Oklahoma, more recently in California, and the Southwest in general. Effects of hurricanes and tropical storms in some areas, winter storms and crop freezes in others, flooding in others, wildfires due to the decreasing rainfall particularly in the West, and severe local storms throughout much of the nation, particularly in the East. This shows the observed U.S. trends in heavy precipitation, like I mentioned before. The only exception is Hawaii, where actually there's a slight decrease. And this is through 2000, I didn't say here, I think this is through 2012. But we've seen a very significant increase in precipitation coming as larger events in the Northeast, followed by the Midwest. What this means is it doesn't necessarily just come as rainfall. You can also get very large snowstorms as a result, because there's more water vapor in the atmosphere. Warmer atmosphere holds more water vapor. In addition, the kind of things we've been seeing in the Northeast in the last 3 weeks appear to be in part related to the fact that the oceans are so warm and it's picking up more moisture and bringing that moisture up at that region. Well, so we've seen that the climate is changing. It's just, everything I've been showing you is just based on observations. Why do we think that humans might play a role here? So we'll go through a little bit of that. First of all, you have to understand the natural greenhouse effect was in the atmosphere was discovered by Fourier in the 1820s, substantiated in laboratory studies by John Tyndall in the UK, in England at that point, in the 1850s, 1860s, and then showed clearly to be working in more recent times through satellite data and other interferometer measurements. Basically, what happens is with solar, the key to our planet having life on it, of course, is that we have a sun. And this radiation from the sun largely penetrates through the atmosphere. About 30% of it gets reflected to space. We call that the albedo of the planet. A lot of that related to clouds and also the ice that you see, particularly at the poles. A little bit absorbed by things like ozone and oxygen in the very upper atmosphere, the very high energy photons. But most of the radiation penetrates to the Earth's surface. Because of the temperature of our planet, again, it's basic physics, that radiation gets re-radiated. It can't just be absorbed, it will be re-radiated. And because of the temperature of our planet, it'll be re-radiated in the infrared wavelengths. Now, if there was no greenhouse gases that could absorb that radiation in the atmosphere, this would be a frozen planet, and there would be no life as we know it. But because of certain gases in the atmosphere, water vapor, carbon dioxide, methane, and some others, they absorb that radiation right in those wavelengths and re-radiate that based on their local temperature. The net effect is like putting a blanket over the Earth. You use a blanket to help you keep warm because it helps trap some of your heat. Well, the greenhouse gases do the same thing. They essentially trap some of the radiation, keep this a warmer planet, and we have life as we know it. Now what's happening is because of human activities, we've increased the amount of carbon dioxide in the atmosphere from about 280 parts per million in the time of the ice ages or the last ice age, to almost 400 parts per million, actually over 400 parts per million now. Now, 400 parts per million, that's 400 molecules per million molecules of air. Doesn't sound like very much, and it isn't, except because these molecules can absorb that infrared radiation, they're really important to our presence of life. But we've increased that amount by over 30%, almost 40%, because of human activities, particularly our burning of fossil fuels and land use change. We've increased the amount of, more than double the amount of methane in the atmosphere, and we've increased the amount of nitrous oxide by about 20%. So we've greatly affected the atmosphere, and these are fairly long-lived gases, so they'll stay there for a long time. I won't go into all the chemistry and physics associated with them, but we've essentially, by adding more of those gases, it's like adding an extra blanket to the Earth. As a result, the Earth should warm more. The basic premise and the basic physics of why we talk about climate change from human activities is because of that process. Well, we know there's natural drivers of climate change, the changes in the orbit of the Earth around the sun. That gives us an ice age every 100,000 years for the last 2 million years. Changes in the sun's radiation certainly has an impact, and we've seen that in the past periods. Not in recent centuries at all, based on models of the sun. We've had very clear measurements of solar radiation from satellites since 1978 that tell us that actually the sun is, if anything, decreased slightly. So the increases in temperature we've had over that time period can't be explained by the sun. And it's very tiny decrease, not much. And then we also know that with very large volcanic eruptions, that can put particles into the upper atmosphere, into the stratosphere. That the sulfur in those eruptions gets converted to sulfuric acid aerosol, and that can reflect sunlight, and you get a cooling effect for several years while those aerosols, those particles, remain in the atmosphere. Mount Pinatubo eruption in 1991 was a clear example, and we saw cooling for several years after that, very clearly. Well, now we've also learned, as was first proposed actually back over a century ago, that humans can also affect our climate by changing the amount of carbon dioxide or methane or N2O or other things in our atmosphere. And the amount of carbon dioxide has increased from about 280 parts per million to over 400 parts per million. The diagram on the upper right is called the Keeling diagram. It's named after Charles David Keeling, and I always like to mention Dave Keeling. He was not only an old friend, but he was a graduate of Illinois, and somebody we're proud of. He developed this very accurate measurement while he was at Scripps in Southern California that allowed these measurements to really show that CO2 was increasing. We could talk about the breathing of the biosphere and so forth, but I won't, which gives you the annual variations in CO2, but we won't have time for that. We also know that particles from fossil fuel burning, particularly, and biomass burning, also play a role in the climate, and we need to account for those. Soot, for example, and as sulfur I mentioned before from burning of coal, gets into the atmosphere, stays in the lower atmosphere, has a relatively short lifetime, but does affect the climate, and we need to account for that. Ice cores are useful in terms of looking at what was the climate like in certain areas, and particularly for these long-lived gases like CO2, what was the amount of CO2 in the past atmosphere? And we can go back 800,000 years looking at CO2 and see that CO2 values vary from about 200 parts per million to about 280, and now we're over 400, over that entire period until the Industrial Revolution, and then it started increasing. Now, so that gives you the basic essence of what's going on, why we talk about human influence on climate. But then there's a whole lots of other analyses that go beyond that then try to look at, well, how do we know it's human? You know, what can we tell about, because of that increase in CO2 and methane, et cetera, and how we might expect that to affect the climate system? Are we actually seeing those things? Can we take some of these severe weather events and actually provide an attribution to the changes in climate as to why those events might have occurred more likely now than they might have occurred otherwise? And so there's been a whole series of such analyses. And I won't go through them all, but the 2011 heat wave, for example, and drought in Texas and Oklahoma resulted in several billion dollars of lost livestock, which is why beef prices have been so high. Because of this major drought, in fact, the drought of 2011 was clearly the worst drought in our experience, as well as the highest average temperatures during that year. As a result, scientists are now going back and trying to pick apart the physics. Now, You can certainly look at the physics of what was happening with the vent and say, oh, it's related to a certain type of high-pressure system and do an analysis of that. And from that, you could say, well, it just occurred naturally. But if you pick it apart and say, well, was that such a system likely to have formed? You find that it was twice as likely to have happened because of the fact the background climate has changed during that time period, affecting the formation of such an event. Another type of attribution analysis is to, for example, look at the observed temperatures globally from 1951 to 2010. This is from the IPCC assessment. And then you can look at the forcing you expect from human activities, particularly the increases in the greenhouse gases, that light green there, and the effects in the particles also released from, which is largely a cooling effect from human activities. And that gives you an overall human effect, an anthropogenic effect, which is the orange there. And you can see if you look at the temperature change, you get just about what was observed. Well, then we need to look at, well, what happened because of solar variations? Well, essentially they're close to zero, as I mentioned before. And even with uncertainties in that, it cannot explain the observed changes. Likewise, internal variability within the Earth's climate system cannot explain what occurred. The only clear analysis or conclusion from this is that it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century, which is the time period when we generally talk about humans having had its largest effects on climate. Let me go a little bit into the future. Well, we continue these projections. You have all these observed changes, and then we try to look forward and say, well, how much are we going to emit carbon dioxide or methane or nitrous oxide in the future? Well, that depends on our choices. And we can continue the pathway we have been, which is heavily using fossil fuels, or we could, particularly over the coming decades, decide we're going to go more and more to alternatives, or for whatever reason, move away from fossil fuels. And you can end up with a different series of scenarios. You just show two of them. And this is looking at the global change. And in terms of degrees Fahrenheit, the high scenario here, which is called A2, which basically assumes we continue heavily using fossil fuels, you get on the order of 7, 8 degrees Fahrenheit increase in temperature globally. It's a lot. 20 degrees cooling, or actually more or less than that, 15 degrees cooling was the last ice age. So we're so 7 degrees is a lot. B1 is a case where we move heavily away from fossil fuels, not as low as we could go. The high actually isn't as high as you could go, by the way. Even that one assumes you still have heavily use of alternatives and so forth. In that low case, you can get maybe down to 3 or 4 degree increase. Still pretty large, and likely to see, many more increases in severe weather concerns, as well as increases in sea level rise, which will likely could occur anyway. Looking at the corresponding temperature change in the U.S. from these, we see about 4 to 5 degree increases by the end of the century with the low case, and with the high case, maybe 8, 9, depending on what part of the country you're in, change in temperature, annual average. Larger in summer than in winter, but overall quite large. What about precipitation patterns? The hatched areas here show where we have the most confidence. White areas show where we don't think there'll be a significant change, or at least not a change that we can analyze at this point. And the brown areas indicate likely to be drier. So we look at winter and spring. The Midwest, Illinois, northern Illinois particularly, is likely to be wetter. Some of that precipitation coming as rainfall, some of it coming as snowfall. Summers are likely overall in the Midwest to be drier than much of the country. By the way, if you look at the Southwest there, the Southwest is likely to be much drier throughout most of these seasons. And then the fall may be slightly wetter, but maybe very little change in this region. The interesting thing in the analysis we did is even though for some of the regions like ours, we might expect an overall increase in precipitation, and more precipitation coming as larger events, which I'm still getting to, for the future, the number of consecutive dry days found in the analyses also were found to likely to increase. So that means you could have a flood, or small flood, heavy rainfall at least, followed by more dry days than we have now. So with the warmer temperatures likely to mean faster evaporation. Not a wonderful thing for farmers, and as I mentioned, I'm a farm boy, so I do worry about what's going on with agriculture. Very intriguing that much of the country is likely to see more days in between rainfalls without rain. Looking at temperatures overall, this is days above 95 degrees. This is based on an analysis that appeared in a recent report, and it looked at a median future, which is kind of a little bit higher than the B1 analysis I showed you, and a 1 in 20 chance is what they is kind of associated with being that high case, although maybe a little higher. And both scenarios show similar changes over the next few decades. We don't see a bit large separation in the scenarios over the next few decades, and seeing some increase in the number of days relative to this very bottom one, which is the number of days we have now, which is like a few above 95 degrees per year, to 5 or so, maybe 5 to 10 in some parts of this region. So an overall increase in much of Illinois. By mid-century, a further increase, depending again on which scenario. And then finally, by the end of the century, seeing much of the summer maybe above 95 degrees in the high case. Very different kind of climate than we see now. Give you a better feeling for that, this is an analysis I developed that appeared in the first National Climate Assessment and has appeared a lot ever since, because people really like it because it allows them to kind of understand what climate change is all about. This just looks at summer average temperatures and precipitation, summer, and looks at where would Illinois be for these different types of scenarios, a high scenario versus that low scenario, the B1 versus the A2. In this low scenario, Illinois ends up being maybe, Arkansas and Louisiana a little bit, whereas in the high case, more like Texas, eastern Texas. I have a son who lives in Dallas area. He moved there in January 3 or 4 years ago to be close to his girlfriend, who's now his wife, and I guess it was 4 years ago. He lorded it over as how nice the weather was in January and February and March. I didn't say a word. Got to be May, and he started seeing every day above 90 degrees. And I just smiled. Then hit July, of course, and many days are above 100, and that isn't what that's not what Illinois is about. And so when Senator Durbin showed this before the Senate, people were kind of shocked by it, except for the senator from Texas who said, so what? But most people got it, that that's not Illinois. Turning to sea level rise, we've seen about 8 inches increase in sea level rise worldwide now. Some areas get more than others because it depends on what's happening with the land, depends on what's happening to, some areas the land is dropping lower, in other places it's increasing. But on average, so sea level rise we know, but not every place sees the same amount. But on top of that, it's also going to be affected by local wind structures and what that means to that region. But on average, the worldwide is about 8 inches. Mostly that's due to the fact that sea level, the oceans have warmed, and that water increases in volume as it warms. For this century, we project it might be more like 1 to 4 feet further. It could be higher. Some analysis, very recent analysis, said it could be as high as 6 feet, 2 meters. But our best analysis right now is say 1 to 4 feet. Now, just to give you a feeling for what that's like. I mean, that's not the most important thing. It's really the storm surges. If you get a large storm, what does that mean to the local region? And the higher the sea level, the more impact you're likely to have. The value of property, of billions of dollars of property below sea level by 2050 could be over $50 billion in the U.S., which is, if you're going to protect that property now and you say, well, we're going to keep it above sea level, you're going to put up walls by the edge of the oceans. Miami's talking about doing that, for example. You're not going to have an ocean front in that case, but you might be able to protect valuable property. Or we're just going to have to move further inland. By the end of the century, that number gets much, much larger. Sometimes I put in, a map of Florida and show you, I don't think I put that in here this time, of what it's like with 3 feet of sea level rise. A lot of southern Florida is gone. I was told, actually, I had breakfast the other day with the science advisor to the National Park System, and he was telling me that a company wanted to build a very large hotel in the Everglades to draw people in to see the Everglades. And the National Park Service was well aware of what could happen with the changing climate and said no, because by mid-century that hotel could be underwater. Well, it isn't just sea level rise, it's really a concern. An additional concern, because of the increase in carbon dioxide, as I said, 25% of that carbon dioxide gets into the oceans, goes into the oceans. The oceans are becoming more acidic, which really means they're becoming less basic, because they start out being quite basic, and they're becoming less basic, which means more acidic. And it's actually measured, and that's what the upper right is showing. You can see it in pH measurements. Analyses in laboratory, and they're seeing this now in actuality off the coast of Oregon, is that as the CO2 is increasing, the size of clams are decreasing, because that additional carbonic acid that you're getting from the CO2 is cutting into the shell development and how well the shells can hold together. What impact that has on sea life and on food supply for us over the century is still unknown. Impacts are apparent in every region and every sector, including health, water, agriculture, energy, and more. And I'm getting behind, so I'm going to have to move quickly. If we look at the Great Lakes region, the effects on the Great Lakes are potentially quite large, but not only because of changes in water level, which we don't think will be huge, but because of changes in the amount of oxygen, the potential for different types of algae, et cetera. Heat waves are projected to increase. I got asked by Mayor Daley 8 years ago to lead an analysis of how climate change might affect the city of Chicago, which has affected policies in the city. And one of those questions they had for us was, what's the likelihood of a heat wave like the 1995 heat wave that resulted in 800-some deaths? And our analysis said by the end of the century, with the high emissions case, you could have 3 of those every year. Even in the low emissions case, maybe 1 every other year. So what was very uncommon becomes common. And as a result, the city has put in actions to have better policies for heat waves. I have really bad allergies, so I always like showing this one, because, actually I don't like showing this one, but we're faced with it. Most parts of the country are likely to see a significant increase in pollen from the longer growing season and more concerns about weeds. Agriculture over the next few decades is likely to be fine in the Midwest. We'll have bad years and good years. By mid-century, we can expect that we're going to see an increasing challenge from heat stress, water stress, pest diseases, and weather extremes in terms of affecting our production without further substantial increases in genetic development and technology. Some recent analyses, paper I'm involved in, suggests we could see as much as a 50% decrease in yield of corn by mid-century. Oh, actually, I put that graph in here. These are based on 4 different models. One of the models suggested quite a bit wetter than the others. This is by mid-century. And, but 3 of the models suggested around 40 to 50% decrease. Great Lakes, I mentioned, I've already mentioned some of the problems with blooms of algae and so forth. I'm going to skip over that. And this just shows analyses that say how water quality in the Great Lakes could be affected by the changes in climate resulting in such algae blooms, dead zones, fish gills, et cetera. Infrastructure and economy, lots of things could be talked about there. One thing we know is with the winters are likely to see a decreased demand for gas and oil for winter heating. We do need to understand what's happening with these stationary highs. Are we going to see more of those? Some scientists think yes, others don't. We don't really know the answer to that yet. Are we going to see more Arctic air, in other words, in our winters? Probably not, though. We don't think that that's going to be the norm. But we know for sure we're likely to see increased demand for electricity in summer, and because of more air conditioning. And again, it depends which scenario we follow. In general, the larger the increase in temperature, the larger the impacts on all these different sectors and other sectors as well, because I haven't talked about all of them. As I mentioned, human activity is the primary cause of the changes we're seeing. That's likely to continue. And future climate change depends primarily on emissions levels and what we continue to do, emitting carbon dioxide, et cetera. We need to know that there are many actions we can take to reduce future climate change and its impacts and prepare for the impacts we can't avoid. In other words, we can mitigate, we can stop the worst of these actions. We don't have to have that high case. We don't even have to have that low case. We can do better than that if we want to. But we also need to prepare for those changes in climate that we can't prevent, and that's called adaptation. So I want to leave you with a sense of hope. Our future depends on how we act to limit climate change. We have to recognize adaptation is not a choice. Our choice is whether to adapt proactively or respond to the consequences. Adaptation does require a paradigm shift, focusing on managing risk. But as Americans, I know that we can draw on our long history of responding to changing conditions and facing the challenges of climate change and meet that challenge. So please look at the website, and I'll be happy to answer any questions you have. I'll leave you with a cartoon.
Thank you so much, Dr. Wuebbles. We have 2 of our Bioneers committee people that are going to come up and man some microphones for us. At least I hope we have 2. Oh, okay. There we go. And so if you would like to ask a question, one of these 2 people will, either you can go back to where Kim is, and or I think maybe Tish is going to help too. So we'll get one of these microphones to you, and you may ask freely. So please, anything that you would like a response from Mr. Wuebbles, please ask. Raise your hand.
Yes.
Is there a direct linear correlation between the amount of heat held in by carbon dioxide, or are there any thresholds that might hold extra, or if we build up a certain amount of heat, would it burst through at some point to get to outer space?
No.
No.
But it's not linear either, though. Actually, because the absorption lines, the main absorption line for CO2 is saturated, it's only the edges of that absorption line that are absorbing the extra radiation. So it actually goes, if you know physics, the math, the natural log of the amount of CO2, not in a linear sense. Whereas for methane, it is linear because it's not, that line is not set, or its lines of absorption are not saturated.
Thank you very much. I have a question about the weather change or global warming has any effect on the invasive species, some imbalance of the, like, Asian carp, so on and so forth.
Yeah.
Thank you.
Certainly we've seen an increase in invasive species that certainly in part related, there's more commerce going on worldwide, which of course helps lead to such things as it's bringing Asian carp into the U.S., and of course they were brought in for other reasons, but not everything is brought in like that. Sometimes it's ships bringing in a species like mollusk, but overall, because of the changes in climate, many of these species are able to survive that would not have been able to survive. We're also seeing things like that are in the U.S., have been for quite some time, like kudzu, the weed that took over the South, as people sometimes call it, is moving northward. And it's even seen in Canada now, and we're certainly seeing it in Illinois. Not in large quantities yet, but as the climate warms, we might see more and more.
This is actually a question from a 7th grader. I'm one of the environmental presenters for our county, and in 7th grade we talk about climate change, and we present the topic of carbon footprint. The average carbon footprint in the United States is 40,000 pounds. Right. The average for the world is 8,000 pounds. And the 7th grader asked the question, if we were able to get to a global level of 8,000 pounds per capita, would that be enough to become sustainable? I said, I have no idea, but I'm going to find out.
I haven't looked at it in that way. I could find out the answer to that. I think the answer is no. I think that we would still see slight increases. And even if the emissions level out, let's just say we go to even emissions from now on, that the amount of CO2 in the atmosphere would continue to increase because we're not at a steady state. The concentration would continue to build. And so we would still see something approaching, maybe not quite as high as that lowest emissions case I was showing you. So it's going to be very difficult to do that anyway, but I don't think the answer would be that it would, that we would reach sustainability quickly.
Dr. Wuebbles, I was curious. I actually have 2 questions. One, since the 1940s, many major world powers have been experimenting with nuclear power, such as the atom bomb, hydrogen bomb, and some countries have even considered using nuclear energy as an alternative for many of our major fuel resources. Is nuclear energy at all tied into the process of climate change? Is it possible excess radiation is affecting the ozone's layer almost ability to filter out everything, or is there no correlation at all?
Very simple answer is no. Now, if we look at nuclear power, could nuclear power, which is already an important part of energy in the state of Illinois, could nuclear power be one of the solutions, at least in the interim? There's a question of whether there's enough uranium available to using the current types of nuclear power for it to be a long-term solution, but certainly in the near term, it could be an important part of the solution. And there is a group that's being headed by, can't remember her name now, Whitman, who was the head of EPA under the Bush administration. Christine, yeah, I talked to her on the phone a few weeks ago. Christine Whitman, that is proposing that nuclear power be actually increased in its use over the coming decades to help relieve this need for energy and without producing major pollutants. Now, you do need to deal with the amount of material, there's nuclear material that is created, the waste, but that's relatively small. And it's not the nuclear power plants that are really the major problems for that. It's really of the many experiments in developing nuclear weapons is probably more of a major issue for the amount of nuclear waste there is around the world.
Thank you. The projections for climate change based upon temperature increasing are dramatic enough. But can you expand on some of the concerns about the release of methane that is such a dramatically more severe temperature riser, and if those were exposed and released?
Yeah, we certainly don't expect to see a major increase in methane resulting from the melting permafrost or from, although there certainly could. I don't want to say it's so well known that that's not going to be a problem this century. It could be. But we don't think that that's likely to be a major issue, or from the methane hydrates trapped near coastal areas. But there is an awful lot of methane there. And if it were released, it would have very large impact, not only on our climate, but also on atmospheric chemistry in many different ways. I've written a lot of papers about methane in the past. It's a legitimate concern, but we don't think it's a concern in the coming decades. It's more important right now, I think, just to slow down the overall climate change so we don't have to worry about that as much. And some people have actually proposed using geoengineering just as a way of trying to prevent some of those things happening, keep the polar areas colder. I think that's very dangerous, though, and something that needs much better understanding before you would try to do that.
Hi, this is sort of getting into the weeds question, and I don't expect you to answer it, but...
Weeds are a real problem with climate change, actually. Farmers are not going to like that.
So you made an argument, a probabilistic or a statistical argument that I think it was the Texas drought or something like that, that you could demonstrate that it was twice as likely to happen because of this background climate change. How would I find that argument so I could dig down in and understand how that argument is structured?
Well, you can send me an email. I'll send you one of the papers. There's been a whole series of papers, but a paper by Horling et al. Is probably the best one.
Which one?
Hoerling.
Okay.
He's with NOAA in Boulder, Colorado, and a whole series of other co-authors, which included the state climatologist from Texas. And that's probably the best one, and that is a very conservative study, because some other studies had said that it's much more likely because of climate change. That one, I think, was the one that said a factor 2. But I'm happy to send you the papers if you'd like. Yeah.
This is another question about methane. What percentage of the warming of the atmosphere can be attributed to the methane in the atmosphere, and what percentage is due to carbon dioxide?
So if you look at the forcing on climate over the last few centuries, and how the forcing on what's called radiative forcing on the climate system has changed, CO2 is, I'm trying to remember the exact numbers, something over half of the forcing, and methane is about a quarter, so it's pretty important.
Additional questions? One right down here. Actually, two down here. If one of you wants to come forward.
I just wanted to ask, do you have anything more to say about the risky business slide that you referred to? Paulson started working with that, and I believe it's getting mentioned in the Wall Street Journal now and then, and you're seeing it popping up in conservative things.
Yeah, the risky business. There's a report that came out looking nationally, and then I guess there's a series of reports coming out, and one of the first ones is for the Midwest, and it's a attempt by economists to look at the economic consequences, and I pulled out the sea level thing from that. Some economists will still claim that it's too early for us to do those kind of dollar cost. I think we got to start digging into it, and whether that's the right analysis. I think that one's pretty clear because there's been other papers suggesting the same kind of levels of numbers. But for other parts of that study, I don't know. I'm not an economist, so it's hard for me to judge. But certainly, I think we need to get more economists involved in looking at this because that's something Congress can understand.
Hi. I know this is probably the worst or the most difficult question, maybe. I hope not. But you read all the different numbers about how much time we have to level off emissions before tipping points hit. Have you done any research and some research on that? Or do you have an opinion?
Well, a lot of us don't like this thing of tipping points because it's not that simple. One could argue we've already reached a tipping point where we're seeing a significant increase in severe weather. And so what do you call a tipping point that's really bad for humans that is not going to be easily recovered? Well, we're probably already there. And then, so if you wanted to look at something like the potential for methane increase or the decrease in, sea ice in the Arctic by over the next 20 or 30 years, is that a tipping point? I think there's a lot of questions that are unclear as to what does that mean, because there's so many other aspects of the climate system that are involved. So that's why I don't tend to really talk about tipping points very often.
Is there information in regard to the human impact of changing the land, such as taking out natural areas and creating heat islands in regard to climate change, just like in the Dallas area is highly developed? Yeah, certainly one of the things we try to include in our studies, it's not, so CO2 has increased about 85% due to fossil fuel burning, roughly, and about 10-15% from land use change. But it isn't only effect of land use change, because as you just mentioned, we also get changes in albedo, the reflectivity of the earth, and are also adding local heat because of building a city. We're still trying to understand just what those mean. And I think they're quite important locally, but probably not. Recent studies suggest those don't have a big impact globally, but locally they can be really important. And so the impacts of those kind of events on the U.S., or those kind of effects of land use change in the U.S. and how that's affected us over the last century is still something that's a subject to study.
Hi, you mentioned Senator Durbin and Mayor Daley, and it sounds like you're maybe a little engaged with the political scene. And
actually not, but I just happen. I've shown politicians from both parties a lot of these kind of things. Yeah, some of them have grabbed them and want to show them elsewhere. So it's fine.
Well, and I hear what I hear in the media about the acceptors and the deniers, and I just wondered if you had a perspective on what's really going on politically after you get past everybody pandering to the base.
Yeah, the reality is that this is a science issue. It's an issue that affects all of humanity. There's no politics behind it. I'm not very much of a political being, in reality. I am interested in learning how the Earth works, and like most scientists, I'm really intrigued by that question of what is going on, how well can we understand it. I find it very strange that there are certain groups that are willing to put out misinformation, like the Heartland Institute in Chicago, and there's others that are well supported to put out misinformation. I'm shocked by the fact that the Democratic Party seems to accept the problem as being real, and that the Republican Party almost feels they have to deny it. I don't understand why. It's kind of, I'm sure there's some psychology there, and I've read some of those things, but I still don't understand it. Don't we want to still, why am I here today? I'm here because I'm worried about, my children, my grandchildren, your children, your grandchildren, and what this means to them as well as to us. And politics don't mean anything in that realm. And because I think most Republicans also have children and grandchildren. So I don't understand this and why they're not worried about the future, or too willing to maybe discount the future. So it's a very strange thing to me. And I've had personal attacks. I don't understand, as a farm boy from Southern Illinois, becoming a scientist. I did not become a scientist to be personally attacked about my science about something that had nothing to do with the science, but yet that's what we face. I've been attacked in the Wall Street Journal, for example. It's just crazy stuff, and I don't understand it. Can they increase the lights?
Could the lights go up? Paul, can you turn the lights up?
Turn the lights up? I can't see who's asking the questions. Really. There we go.
Even if the United States and Europe initiated, I would think they would have to initiate something like an extent of a Marshall Plan to retrofit their economies to run on sustainable energy. But wouldn't that drive oil and coal prices into the dirt? And do you really see the rest of the world giving up on oil and coal, even if we tried to wean ourselves off of it?
So first of all, many oil companies have told me for a long time period that there's plenty of other uses for oil besides burning it. We get plastics, all kinds of other things from oil. So there's lots of things we could do with oil. Secondly, with coal, I'm not against burning fossil fuels like coal, as long as we take that carbon and remove it. And in fact, if you use coal gasification, it not only removes the carbon, and you could potentially bury that in an old mine or something. And there's geologists are doing studies to see how effective that would be right now. But it also removes the mercury, the sulfur, and some of the other pollutants. And so you would overall have, with a slight cost in energy, because you have to put in some energy to do the coal gasification. But there is technology that's been developed, is being developed, that will allow us to use coal, but without the consequences. So I don't. There's been many analyses. Go read this Risky Business report, for example. You can get it off the web. It suggests that, and likewise, the Stern report from the UK is the same thing, that there are technologies out there that we would not really change our way of life. And we can do this cheaply enough without a major impact on our society. We just have to have the willpower to do it. Are we done? No?
Well, in fact, I'm going to ask the one last question, and that is, Dr. Wuebbles has said that he's not involved with politics, but obviously he interacts a lot with our government officials as well as government officials throughout the world. And I would just like to ask, can you share any of your thoughts on what hope there is nationally and worldwide on getting some serious changes made to prevent some of the highest scenarios you've been showing us?
Sure. I've testified before Congress a number of times, et cetera. There was a recent vote in the Senate. This was after the new Senate, which was Republican, in the majority. And the first question asked was, is our climate changing? 99 out of 100 said yes. Second question was, now I'm going to get this wrong because it was said two different ways. But one of the ways was, is the climate changing because of human activities? And then I think the final one maybe was with carbon dioxide in particular. But anyway, they did not get it. They did not get half. They were close to half in both cases. And in the final case, 5 Republicans, including Senator Kirk from Illinois, voted yes. That's a change. So I think there's some signs that, and we're seeing many other signs, that the Republican Party is maybe starting to get it, just haven't quite been able to kind of escape the politics right now to come out outright and say it. I've heard from talking to various people in Washington who know a lot of congressmen and senators personally that privately they will almost all say, yeah, it's an important issue. They just won't say it publicly. On the worldwide, we'll have the next major meeting will be in Paris in this summer. And will it result in a major movement? It's not clear. I do know that there's going to be certain pressures brought to bear. The Pope is about to bring out an encyclical that says this is a really major issue affecting the people of the world, going to have huge impacts on the poor people of the world in particular, and we need to be concerned about it and doing something about it. That's another movement towards perhaps something happening. it's going to be interesting to see what comes out of this summer's meeting. I don't know for sure. But I'm hearing some sense that there may be much more actions happening worldwide than there have been up to this point.